All right, next lesson. So now we are dealing with the normal distribution or the empirical rule. So we're going to put all of that together, all right? When we are dealing with the empirical rule or normal distribution, we're going to look at the percentage of how far our data is spread out from our mean, okay? So everything we've done so far is going to fall back to this. Now, if you are doing, and if you look at the bottom of this thing, it says the line plot for a normal distribution is a bell-shaped curve. That is what it looks like, something like this right here, okay? This is what your data should look like anytime. That's what you want it to look like. Of course, there's going to be times where it's skewed to the left or skewed to the right. But right center is always going to be my mean, no matter what. Let me do that in a different color just so you can see it. But that's always going to be, all right? Now, if I continue on, if I go one standard deviation higher and one standard deviation lower, this information right here is one standard deviation within my mean. So it's 68%. It's always going to be 68% between these two lines right here. Okay? If I go out one more, this is two standard deviations. Okay? This is going to be two standard deviations. And this is always within 95% of my mean. All right? If you go out one more, then you're going to have three standard deviations. All right? So you get the concept of what's going on. And that is going to be 99.7% of my data. 99.7, 99.6. It depends. This is the actual normal distribution curve. As I said, this is always my mean right here. And that's going to be given to me at the time. Sometimes I'm going to have to find it. But my mean is always right center, okay, because that's exactly where I want it to be. All right, because that is my. Now, 68% is within one standard deviation, so within one. So I am negative below, I'm positive one higher, all right? The next one is within two standard deviations. So if you go out one line more, that's within two standard deviations, okay? You go out one more, you're within three standard deviations. Now, I will go ahead and tell percentages that are listed. So this 34 and 34, those will always be there. These are always going to be the same. So you can memorize these. Your numbers are going to be 0.2% for anything bigger than three standard deviations left or right. Then you're going to have 2.2%. Anything between 2 to 3 standard deviations higher or lower. Next, you're going to have 13.6% for everything within 1 to 2 standard deviations higher. And then the last one is going to be 4%, and that's going to be within 1 standard deviation higher or lower. If you can memorize these four numbers, then you're just going to repeat. It's going to be 0.2, 2.2, 13.6, then 34. Then you're going to start at the top and go down. 34, 13.6, 2.2, 0.2. So you just need to memorize that. That is an easy thing to remember, but this you're going to use for this section and the next section. Okay? All right, so the height of 3,000 at a particular college normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. Okay? About how many of these men have heights between 65 and 67.5 inches? All right, to find this, we need a shaped curve. So we're going to draw that out. Okay? We always have the center, and then we go 1 standard deviation lower, 2 standard deviations lower, 3 standard. Then we're going to do the other side. 1 higher, 2 higher, 3 higher. All right? Now, go ahead and put percentages in there. Again, 0.2, 2.2, 13.6, 34. And then I'm going to start from the biggest number and go down. 34, 13.6, 2.2, and 0.2. Okay? Now, that is memorized. That will always be the same for every problem you do with normal distribution or the empirical rule. Okay? My mean is always going to be my middle line, which is right here. Well, if I read in here, it says I have a mean of 65 inches. So 65 is going to be here. All right? Well, my standard deviation is 2.5. They've already figured it for you. You did not have to figure that. So in order to know on the other bars, if I'm going down, I'm going to subtract 2.5 from 65 for this next one. That's going to give me 62.5. So I subtract 2.5 from this one, it's going to be 60. If I subtract 2.5 again, 57.5. So I have that side completed. Now if I'm going to go this way, then I'm going to add the 2.5, okay, every time. So that's going to be 67.5, 70, 72.5, okay? So subtract 2.5 if you're going down, add it if you're going up, okay? Now our question says, how many have heights between 65 and 67.5? If I look at my chart, where is 65 and 67.5? Right here. All right, so I know that 30%, and I should have put my percentage signs here, sorry, that is a percent. That's not my total number. So if I know that I have 34% of my women that are between 65 and 67, I know I have 3,000 women. I have everything I need. So I'm going to take 3,000 and multiply it by 34%. And if you remember, we changed our percentages to decimals, which would be 3,000 times 0.34. And then when you put that in the calculator, you're going to get 1,000 women. So that's how many women are between 65 and 67.5%. Or sorry, inches high, inches tall. So 34% of my, which is 1,020. All right, the next one. So find the probability that a randomly selected college woman has a height of at most 68 inches. We're not going to do that one because that gets into Z-score. We're going to do that later on. So just cross this one out. You have to do this one. Okay? All right. About what percent of women have heights below 60 inches? So I'm just going to draw my normal distribution curve again. If you want, you can go back and look. And then, all right, there is that. And then we have 60 or 57.5, 60, 62.5, 65, 67.5, and then 70 and 72.5. Okay. And then, of course, our percentages, 0.2%, 2.2%, 13.6, 34, 34, 13.6, 2.2, and 0.2. Okay? So it says, what percent of college women have heights below 70? So that means from here down. What is our percentage? It's asking for our percentage. Well, guess what? It's already set up in percentage form, so all we have to do is do 0.2 plus 2.2 plus 13.6. Sorry, that should be a plus, not another decimal. Plus 34 plus 34 plus 13.6. All right, and then all I have to do is add that together. Now, if I add that together, I'm going to get 97.6%. Okay? So 97.6% is what you get for that. And that is about how many women are at least 70 inches or below. They are no taller than that. All right, let's go to the next one. So, how many college women have the between 60 and 65 inches? Okay, so there's 3,000 women. Okay, and instead of on the thing again, I'm going to go back and look. So we're looking for between 60 and 65 tall. All right, so that means we are looking 60, 65. So we have 13.6 and we have 34. So we're going to add those two percentages together, okay? So 13.6 and then plus 34%. When we add that, we get 47.6%. If we change that to a decimal, it's 0.476. And you need to use all of those numbers, okay? So 3,000 times 0.476, put that in your calculator, and you're going to have 80 people. It's going to be 1,428 women are between those two things. All right. Find the probability that a randomly selected college woman has a height of at most 61 inches. We're not going to do that one either because it is getting into Z-score, so we'll do those in the next section. All right? All right. So a normal distribution has a mean of 25, standard deviation of 5. So let's go ahead and draw that out. So let's do our bell-shaped curve. It's not going to look exact every time, but in 1, 2, 3, 1, 2, and 3, I have a mean of 25 and a standard deviation of 5, so add 5, so 30, 35, 40. Then on this side, I'm going to subtract, so 20, 15, and 10. Now, I can't forget my percentages. That should be memorized. 0.2%, 2.2. And you don't have to put the percentage signs as long as you remember that it is percent. So 13.6, 34, 34, 13.6, 2.2, and 0.2. Now, you should only have to draw this one time because it'll cover all of them, but I'm going to have to draw it again when we change pages, okay? All right, so the probability of it being between 20, or if you look here, this is less than or equal to, so I can use 20. So I need to go from 20, x is greater than or equal to 20, and it's less than or equal to 30, so right here's 30. So if I look at this, if I add those two percentages, since it's probability, it's going to be 68%. That's within one standard deviation. Okay? If I look at the next one, x is greater than or equal to 20. So I need to start here at 20, and I need to go all the way up. So I'm going to add 34 plus 34 plus 13.6 plus 2.2. Okay? If I add all of those up, or if you add them all up in your calculator, you're going to get 84%. Okay? All right, so anytime it has the P, that's the probability. You don't have to worry about now if it asks how many, you want to multiply it by the number it gives you, okay, of how many people were questioned. But anytime it's probability or percentage, you're just going to add those up. All right, the next one, let me go ahead and redraw this real quick. So we had 25, 30, 35, and 40. This way we had 20, 15, and 10. Again, 0.2, 2.2, 13.6, 34, 34, 13.6, and 2.2, and then 0.2. Okay, so I've got my percentages lined up. Now, if I look up here, I need to be less, or 15 is going to be my smallest number, so here, and then it's going to be less than or equal to 35, so right here. So I'm just going to add those numbers up, 13.6 plus 34 plus 34 plus 13.6. And you can do that in your calculator or whichever, but you're going to get 95.2%. Okay? All right, and the last one is going to be 35 or greater. So right here at 35 and up. So all I'm going to do is do 2.2 plus 0.0.2. And that's going to give me 2.4%. Okay? So that's exactly that. The next section, we're actually still using the empirical rule and stuff, except we're going to get into stuff that's in between the standard deviations. But there will be plenty of practice on it. And let me know if you have any questions.